A quantity of electrical charge deposits 0.750 grams of silver from an aqueous solution of silver nitrate. When the same quantity of charge is passed through a solution of gold salt, 0.456 grams of gold is formed. What is the oxidation state of gold in the salt? So to answer this problem, we will make use of the equation M is equal to capital M IT divided by NF. So if you're still not familiar with this formula, the lowercase m or the small m stands for the mass and the unit is in grams. The capital M stands for the molar mass and the unit is in grams per mole. I is the electrical current and the unit for electrical current is amperes. T is the time and the unit for time is seconds. In the denominator, we have here N, which stands for the oxidation state, and F stands for Faraday's constant. And the unit for Faraday's constant is coulombs per mole. So, another formula you need to familiarize yourself with is Q equal to IT. Q here stands for electrical charge. So as you can see in the problem, it's mentioned twice. Electrical charge or charge. So that's Q. We already know that I is amperes, I is the current in amperes, and T is the time in seconds. So Q is equal to IT. Therefore, we can actually substitute the IT in the first formula with Q. So instead, we can write that as M is equal to MQ over NF. Okay, I hope that's clear. So we will be using now this formula to answer this problem. Okay, so in this problem, we are given two elements. So let's divide our screen by 2. So we are given silver and gold. So silver, it's in the form of silver nitrate. So AgNO3. So silver nitrate. And we know that in silver nitrate, what is the oxidation state of silver? It's +1. So the oxidation state of silver in silver nitrate is +1. On the other hand, we have gold. But the problem is we do not know the salt because the problem just says gold in the salt. So unlike silver, we know that the salt is silver nitrate. However, for gold, we don't know what the identity of the salt is. So we can't actually know right away the oxidation state of gold. So let's just say we have gold and the oxidation state is unknown. So let's just say positive X. So X because we don't know yet what is the oxidation state of gold. So since we already know the oxidation state of silver, so let's work with silver first. Let's use the formula and apply it to silver. So let's follow the formula. M is the mass deposited, which is 0.750 grams. That's equal to, capital M stands for the molar mass. If you look at your periodic table, the molar mass of silver is 107.87 grams per mole. We don't know what Q is, so just write Q divided by N stands for the oxidation state. So we know that silver is Ag +1, so +1, +1. And F is the value of Faraday's constant. So please memorize the value of F or Faraday's constant because teachers usually don't give this, especially during exams. So you need to memorize the value of F, which is 96485 coulombs per mole. So I will just omit the units. Okay, so basically we are missing Q. So we can actually solve for Q. So how do you do that? So to solve for Q, we will multiply both sides of the equation. Okay, so we will multiply both sides of the equation by 1 times 96485. Okay, so you do that on the right side. You also multiply the left side by 1 times 96485. So on the right side, the 1s and the 96485 would cancel. So what's left on the right side is 107.87 times Q. On the left side, grab your calculator. You can actually solve that. 0.750 times 1 times 96485. That is equal to 72363.75. And if you want to solve for Q, you just divide both sides by 107.87. So you also need to do that on the other side. So 107.87 would cancel on the right side. So what's left on the right side is Q. So on the left side, you have 72363.75 divided by 107.87, and that's equal to approximately 670.84. So the value of Q is 670.84. Now the problem says that, if you look at the second sentence of the problem, it says, when the same quantity of charge is passed through a gold solution. So that means the same value of Q is used for the gold solution. Okay, so that means in our second column, Q remains the same. Q is still 670.84. Now we will use the same formula. M is equal to MQ over NF. So in the problem, the mass deposited was given. It says here 0.456 grams of gold equals the molar mass of gold. If you look at your periodic table, the molar mass of gold is equal to 196.97 grams per mole times Q. We already know the Q. It's 670.84 divided by N is the oxidation state. However, we don't know the oxidation state of gold because that's the missing one in the problem. So just write N times Faraday's constant. You need to memorize this again, 96485. So how do you solve for N, or the oxidation state? So what you do is you multiply both sides of the equation by N times 96485. So you also do that on the left side. So on the right side, the N would cancel out, the 96485 would cancel out. So what is left on the right side is 196.97 times 670.84. And on the left side, we have N times 0.456 times 96,485. So if you want to solve for n, you need to divide both sides of the equation by 0.456 times 96,485. So the 0.456 and the 96,485 will cancel on the left side. So what's left now on the left side is N, or your oxidation state. And on the right side, you grab your calculator. That's 196.97 times 670.84 divided by 0.456 times 96,485. And the answer must be rounded to the whole number because it's oxidation state. The answer is equal to 3. So the oxidation state of gold in the salt is positive 3, or you can write it as gold plus 3 or gold 3 plus. So this is the answer to the question.